Hey guys, quick tutorial. Today I'll be teaching you how to implement aircrafts using the vehicle node, so let me show you what I got so far. As you can see, we have our vehicle right here. We're able to move around as normal, except we have two states. We have our ground state, as well as an air state, which we can access by getting enough momentum, so we can pry ourselves from the floor. Once we're in the air, we can maneuver, we can make turns, and if we press tab, we also have the ability to lock our camera, so it's always facing forward. And finally, once we land our vehicle, we re-enter our ground state, just like that. So that's pretty much it. So let me show you how I did that. So first things first, what we're going to do is we're going to do our vehicle setup. So let's just delete this for the time being and open up our GLTF file. So the very first thing that we're going to do is we are going to click on our spatial node and change the type to a vehicle body. Then we're going to click on the body mesh, click on the mesh tab here, and click on single convex collision sibling, and then drag the mesh into the collision shape. After that, what we're going to do is we're going to make sure everything is in the right position. So we want to make sure that this is in the center by lifting everything up by 1 and dragging everything back by 0.3. So that way everything is aligned. After that, what we're going to do, we go to our wheels. Let's start with our left wheel. We're going to click on vehicle body motion. We're going to use traction as well as steering. We're going to change the wheel radius to 0.22. We're going to change the suspension travel to 0.1 and our stiffness to 50. We're going to do the same thing for the other wheel as well. So click on the right wheel, traction, steering, 0.22, suspension travel 0.1, stiffness 50. For our back wheel, what we're going to do, we're going to leave this alone. We're just going to go to our wheel, change the radius to 0.1, change suspension to 0.1, change the stiffness to 50, and finally we're going to change our rest length to 0. And that's pretty much it in terms of setting up your vehicle. We're just going to change our weight real quick to 1600, and then we can start working on implementing a camera. So for the camera, what we're going to do, we're just going to do it the same as our last vehicle. We're going to add a spatial node, which is going to be renamed to camera. We're going to add a spring arm. We're going to change it to layer 2. We're going to change the spring length to 5. And finally, we're going to add a clipped camera. What we want to do after that is lift everything up by 2.5. So just here. And then we can start working on our camera script. So the very first thing we want to do is we're going to go to our project settings and make sure we have a new key input called tab. So to do that, we type in tab, click on the plus sign, key, tab, and then we can attach a script. So this is the same script we had before for our previous tutorial. The only difference is we have a new variable called camLock. So var camLock is equal to false. And we also put this check down here. So the reason why we put this check here is because these lines of code are responsible for rotating our camera. So if our camLock is equal to true, we don't want this to happen. After that, everything here is brand new as well. So I'm going to retype everything. So the first thing we're going to do is toggle between locking our camera and unlocking it. So if input.isAction just pressed, tab, if our camLock is currently equal to false, we'll set it to true. Otherwise, if it's currently true, we'll set it to false. After that, what we're going to do is we're going to lock our camera in place. And to do that, we're going to check if our camLock is equal to true. And if it is, we're going to set our rotation radians. So our rotation.x, lerp angle rotation.x to 0. So basically facing forward at a speed of 0.1. We're going to apply the same thing for our y-axis as well. Lerp angle rotation dot y 0, 0.1. And that's pretty much it in terms of setting up your camera. So what we're going to do is save this scene as define.tscm. We're going to go to our world. We're going to add it to the scene. And we're just going to test the camera. So as you can see here, camera works as normal, but if I press tab, it faces forward no matter what angle. That's exactly what we want. So after this, we can start working on our vehicle itself. So let's go to our Defiant and rename this Defiant, and let's attach a script. So as you can see, everything is pretty much the same as before in our vehicle script. The only difference is we had a new variable called grounded, which we're going to be using to check if we're on the ground or not. And everything here is new. So we're going to do everything from scratch. So to do this, what we're going to do is we're going to have function integrate forces. And we're going to create some checks to see if we are currently on the ground and if we're trying to take off or if we have taken off. So to do this, we're going to have if grounded is equal to true and input.isAction pressed shift. And this is a little bit complicated, but I'll explain it in a second. If transform.basis.xform underscore inv linear velocity dot z is less than equal to -8, grounded is equal to false. So basically, if I explain this in the simplest terms, we're getting our transform basis, so our local rotation, and we're getting the linear velocity along the z-axis, so basically our forward momentum, and we're checking if it is currently -8 or less. So if we're moving, well, -8 or less, so we're faster. And if we are, we're going to be setting our grounded to false because we're trying to take off. And the second thing we're going to be doing is also checking if our wheels are currently in contact with the floor. Whoops. Is in contact. And the left wheel is in contact. Grounded is equal to false. So we're also checking if both our wheels aren't in contact with the floor, it means that we're in the air, so our grounded is set to false. Otherwise, if we're currently in the air and we are not pressing our shift, if our wheels are in contact with the floor, our grounded is equal to true. So that's all self-explanatory. If we're on the floor, we're setting our ground to true. If we're not on the floor, we're setting our ground to false. Now what we're going to do is create our behavior for when we're in the air. So if grounded is equal to false, we'll be doing the following. We'll be having our throttle, so our forward momentum. So we'll be doing the same check as before, except we're doing it to a lesser extent, because if we're going straight up, the tendency is our value might drop below this amount. So we'll be doing if transform basis is less than or equal to -6, and our linear velocity is equal to lerp, linear velocity negative transform dot basis dot z times by our horsepower divided by 20 by our acceleration speed divided by 20. So we want to keep it relative to our engine power. It's sort of basically the same kind of code we used for our bullet script. So if we go to our bullet script over here, we see that we get our transform basis .z, and then we assign a value. So this is kind of the same thing that we're doing here. We're getting our transform z basis times by a horsepower divided by 20, because this is a relatively big number, and times by the speed of acceleration divided by 20. Yeah, and that's pretty much it. So what we're going to do after that, we are going to work on our steering. So with our steering, we can't actually apply rotation to physics objects, so we have to apply a angular rotation. So the very first thing we're going to do is get our inputs. So var input is equal to negative input dot is action get action strength w plus input dot get action strength s var horizontal input get action strength plus input dot get action strength d, and we'll be getting our angular velocity. So basically our rotation, lerp it by our transform basis dot x times our var input. So we are getting our, along the x-axis, timesing it by 1 or 0, plus transform basis dot z times by horizontal input, and we'll be moving at a speed of 0.1. Yeah. So that's pretty much it in terms of steering. Let's remove all this. And the very last thing that we're going to do is, once we're in the air, we want to make sure that our engine isn't running for any reason. So we'll just write turn off engine force is equal to 0, our steering is equal to 0, and finally our brake is equal to 0. Almost there. The very last thing we want to do is we want to make sure that our propeller itself is rotating. So what we're going to do, as you can see on our z-axis, we're just basically going to be modifying this value. So let's go back to the script. We'll get our animation. I'm going to get our node. Let me just remove this. Propeller mesh dot rotation dot z plus equals 0.4, and that pretty much should be it. It was a lot to take in, and we haven't tested the code yet, so let's hope for the best and press play. What we want to do before then is we want to make sure that this is not inside this bracket. So we'll have it here, save, press play, and let's hope for the best. So let's see, we have it here. We can move around. Let's get some momentum. Hold shift. We come off the ground, perfect. We're able to rotate. Press tab. Everything fixes front. And finally, we can land our vehicle and hopefully re-enter the ground state. And just like that. And that's it. That's pretty much it. If you guys enjoyed this video, if you learned something, thought it was helpful, feel free to, write a comment, whatever. And yeah, give me some suggestions. I'll look into it. And that's pretty much it. Thank you so much for watching, and have a great day. One last thing before I go. For those of you who want to have both vehicles in the world at the same time, I'm just going to show you how we'll be able to do that. So as you know, if both vehicles are in the scene at the same time, the tendency is because they both run on the same script. Ooh, let's not do that. They both run on the same script, so you can't control them individually. So what we can do to fix this actually is we can check which camera is currently active. So to do that, what we're going to do is we're going to go to our Humber script, and we're going to write if our clipped camera dot current is equal to true, then we'll indent everything like that. Same thing for here. Let's indent everything here. And finally, we're going to go to our camera script and do the same thing. We're going to write if spring arm slash clip camera is equal to true, dot current is equal to true. Let's indent everything here and do the same thing for our physics process as well. So that way, if we run our script again, you'll see that we can move our vehicle independently from our Humber. But we also want to be able to switch between vehicles as well. So the only thing we need to do is switch the camera. So actually what I want to do as well for the Defiant is add the same principles. So if our clip camera dot current is equal to true, have all this, and finally same thing for our integrate forces as well. With tab, Sfeet. And finally, we're going to do one last thing. Let's go to our project settings. We're going to be adding this key binding 1. Let's go to world. Let's add a script to world. It's going to be a physics process. Function physics process. And basically we'll be getting the Defiant we'll be getting the cameras of each. If input.isAction just pressed 1, if Defiant dot current is equal to true, is equal to true, else is equal to true. So let's just test this out real quick. If I'm here, I'm able to move. If I press 1, I switch vehicles. Press 1, switch vehicles. Just remember to brake before you switch vehicles. And just like that. And that's pretty much one way you can switch between vehicles. It's just using the camera as the method of assigning which one is active. And that's pretty much it. Thank you so much for watching. Have a great day, and see you next time.